Awesome. That was my first thing I wanted to talk about. Again, sort of like housekeeping. The other one is I wanted to remind us. So if we have not finished our IXL diagnostic, okay, that was what I really wanted us to do last week. All right here. Sloan and Andre, I need you to finish it. And then Nash, Landon, and Jason, I'd really like you to start it. Okay. So those are our two. Again, I'd really like us to try to get that done ASAP so that we don't really have to worry about it anymore. Okay. I am going to pause for a second. I'm going to get my iPads fired up here and then we will jump in. So make sure you've got a writing utensil and something to take notes on. And we are going to jump into our review right now. Okay. I thought I couldn't find my cord. It was just hiding behind my computer. So we're all set. Let's rock and roll. Allow, sure. Yeah. So again, make sure you've got something to write with and we will get going. All right. Again, this is November 17th. Why is it not going? Plug it back in. There it goes. All right. So one of the first things that we sort of talked about this, or again, last week was all IXL. This week we started talking about LCM. Can we type into the chat? What does the LCM stand for? Does anyone know off the top of their head? Give you a hint. Least common multiple, LCM. So what this means is that if we take a number and we'll even add variables in as well, but when we take this number, we want to find multiples of numbers, and then we're going to figure out which of those multiples are the same, and then we want the first one that comes to mind, or the least. So let's just randomly pick some numbers. How about 12 and 16? So first thing I'm going to do is I'm just going to start counting by 12s. Again, counting my multiples. 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 48, 60, 72, 84, 96. If we have to go higher, we will. So one way to think about it is 12 times 1, 12 times 2, 12 times 3. The other way is to think about it like 12 plus 12, 24. 24 plus 12, 36. 36 plus 12, 48. Because multiplication is repeated addition. Now we're going to count by 16s, or again, multiply 16 times 1, 16 times 2, 16 times 3, and I think this would be 16 times 4. So I actually have enough information here to solve this. I can say, okay, the number that they have in common, and if I kept going, I'd find more, but the number that they found that is the least common multiple is going to be 48. Now, sometimes it gets a little bit more confusing because this is, again, more like pre-algebra. What if we had something like this, where we had 12a to the third and we had 16a to the fourth? So now again, my number, everything I did with the number would be the same. So right now I'm going to focus on this. I'm trying to find out when is a to the third and a to the fourth going to have the least common multiple. So again, as I go through this, a to the third, the first term, then I'm going to add 3 more a to the thirds, or else it's called a to the sixth. And then if I add 3 to that, it'd be a to the ninth, and then a to the 12th, a to the 15th, so on and so forth. I'm going to look at a to the 4th and say, okay, I've got a to the 4th. If I double that, a to the 8th. Again, if I add a to the 4th times 3, I get a to the 12th. Bing, 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 bing. Okay, we found that a to the 3rd and a to the 4th have a LCM of a to the 12th power. So if the entire question was, what is the LCM of 12a to the 3rd and 16a to the 4th? Again, I would look at the numbers separately, and then I would look at the variables. So I would say that it would be 48 a to the 12th. That would be my LCM. That was one topic. Again, we kind of had a lot of less. We kind of really jumped into it. The first week of the quarter was a short week, a little bit easier. This week we had 4 new lessons, and then I'll probably share next week again because we have people traveling and it's Thanksgiving break, fall break. So if you are going to leave town, again, you've got some IXL and a quiz. I'm going to share that with you at the end of the Class Connect. So if you want to work ahead, if you want to get ahead because you're going to be you're going to be busy next week, that is a-okay with me. All right. Real quick, we talked about terminating decimals versus repeating decimals. Can anyone maybe unmute or type in the chat? Does anyone have an idea? What is kind of the difference between terminating and repeating decimals?
Repeating is basically like going on forever.
It is absolutely, and there's going to be some sort of like pattern that goes along with the decimals. So some numbers go on forever, but they don't repeat themselves. So like one example would be 0.3333. Again, as that goes on forever, it's going to be 333333. We can write that again like this, and we can put a line over it. If you put a line over it like this means that the 3 goes on forever. We could also have a repeating decimal that looks something like this. It could be something like 0.12121212, where again, the 1 and the 2 are going on forever. So if I were to use that line idea, I would put the line over the 1 and the 2, and it's going on forever. Terminating doesn't really repeat. And if you think about, your English class, a synonym for terminating, I would say means to stop. So if we had a number that was like 3.15, that's it. It stops. There's nothing left. We talked about sticking with our decimals idea. We talked about how to write decimals as fractions. So it's really going to depend how far are we going past that decimal point. So if I said 3.1, let's stay with 1.5, okay, a terminating decimal. I have 3 whole units. So again, as a decimal or as a fraction, I'm going to say it's a 3. And this goes from my 10th place to my 100th place, okay? So I would write this as 15 over 100. So I have to determine how far away, how many numbers do I go past that decimal point, and I'm going to count by tens. Or I'm going to add a 0 to my number, not count by 10. So it'd be 10th place, 100th place, 1000th place, 10,000th place, on and on and on and on and on. We'll do one more example. Maybe we say 2.005. So again, my whole number is a 2, and then I go 1 place tenths, 2 place hundredths, 3 place thousandths place. So I'm going to say 5 1,000ths. 2 and 5 1,000ths. Again, this is a whole number. 2 is a whole number. So that's why we have to have it much bigger like that. And the last, probably the biggest one, and this is the one I'm going to let you get some practice on, is adding, subtracting, multiplying, and dividing fractions. So again, I'm going to go real fast here. I know that, but you can go back and rewatch those videos, rewatch those lessons where it's going to take much, it's going to go much, much slower, and we're going to do more examples. Adding, okay? If we're adding fractions, what we need to make sure we have is a common denominator. What does that mean? Does anyone know?
Is it like the bottom?
It is the bottom, and that word common means it is the same, okay? So we've got our numerator on the top, the denominator on the bottom. When we add or subtract, because really the rules are the same, so we'll combine this, okay? When we add or subtract, we need this common denominator to be the same. Okay, so let's do an example. Let's say we've got 7/10 minus 2/10, okay? Because I have the same denominator here and here, I can go ahead and subtract my numerators. And I can say 7 minus 2 over 10. I subtract the numerators, I keep the denominator the same. 7 minus 2 is 5/10, and we always want to simplify our answer. So 5/10, if I think, what do 5 and 10 have in common? They have a 5. So I'm going to divide by 5 on both sides and get 1 over 2. Let's do one where we have to change it, and we'll add a whole number in there. Again, I know I'm going to go real fast here because I want to give you some time to practice on your own. Let's say that we have 3 and 4/5, and I want to subtract 1 and 1/10. So first thing I'm going to look at, there's two ways to do it. I'm going to do it this way where I'm going to subtract my whole numbers. Okay. So 3 minus 1 is 2. And then I'm going to look at my fractions. And my fractions tell me 4/5 minus 1/10. So 4/5 minus 1/10, they do not have the same denominator. So I need to change one. And the easiest one that I can do to change is change 5 into a 10. So I'm going to multiply the top and the bottom by 2. Whoops. Okay, so 2 times 4 is 8. 2 times 5 is 10. And now I can do 8/10 minus 1/10 and get 2 and 7/10. So my answer would be 2 and 7/10. Again, the key, you need a common denominator. Multiplying fractions. We don't necessarily need a common denominator. It's nice if we have one, but we don't always need it. So if I take, let's say 3/4 times 1/2, I'm going to multiply the top and multiply the bottom. 3 times 1 is 3, 4 times 2 is 8. Now I need to say, is there anything I can do to simplify? The answer is no. So I'm done. When you multiply, you do not necessarily need common denominators. Okay, let's try a mixed number. So let's say 2 and 3/4 times 1 and 1/2. I recommend, and again, there are other ways. There's a couple ways. It's cool about math. We can solve things a lot of ways. I would recommend turning this into a mixed number. So that means I'm going to multiply by the denominator and I'm going to add the numerator. So this tells me 2 times 4 is 8. 8 plus 3 is 11. So I'm going to rewrite this as 11/4. Let's do that again. Multiply by my denominator, add my numerator. 1 times 2 is 2. 2 plus 1 is 3. So I'm really getting 11/4 times 3 over 2, which gives me 33 over 8. And then we just want to see how many times does 8 go into 33? 8, 16, 24, 32 with 1 left over. Real quick, we're going to do division so that you get about 5 minutes of practice time again on your own. I've got some problems for you. When we divide, we actually turn things into multiplying. And the key to doing that is to keep, well, the math term is multiply by the reciprocal, which is keep, change, flip. So again, whatever my number is, 3/4 divided by 1/2, I'm going to keep my first number the same. I'm going to change my division sign to multiply, and I'm going to flip my numerator and my denominator. This is called multiplying by the reciprocal. 3/4 times, flip it, 2/1. 3 times 2 is 6, 4 times 1 is 4, which means we get 1 2/4, which means it is 1.5. So that was, again, the key to dividing fractions is to multiply by the reciprocal. That was super, super quick. I know that. I want you guys to practice, so I'm going to get something pulled up here. I'm going to put a link in the chat, and then you're going to get some time to practice. Let's see where it is. There it is. Perfect. All right, continue. All right, I'm posting the link in the chat right now. Nope, that's not it. There it is. All right, click that link, please, and we will get started ASAP. Okay. I'm going to share my screen for those of you that are watching the video, and you can do these practice problems on your own. Again, pause the video, try the problems on your own first. Again, if you're not in, we only have 3 people in right now. Please click that link in the chat box so that you can get some practice. We got 4 people in now. That's great. 5. This is the one we were on. Again, if you're watching the recording, please pause, try the problem, then hit play afterwards. Okay, we're gonna wrap up. Again, I know that we went by real fast. It looks like we may need a little bit more practice with this, and that's totally okay. Next week, there are a few different IXLs where we're gonna practice. So you'll have plenty of time to practice this before you take your quiz. So to wrap up, again, if you didn't finish, that's totally all right. Not worried about that. Just kind of wanted to see where we were at. Let's review Schoology real quick and talk about our Class Connect assignment. Remember, everybody needs to do this to get your credit, okay? That's Mr. Larson's rules. So I'm going to go ahead and publish next week. So again, if you're traveling or if you're doing something and you want to work ahead, absolutely go ahead. Again, all it is IXL practice, which I do think we need a little bit of practice, and then we're going to take our quiz. If you look in your Class Connect assignments folder, you'll see today's date and our assignment. There's going to be a couple problems from the assignment. So just to help us set it up, okay, I'm not going to tell you the answer, but I am going to help you set it up. All right. 1/3 plus 1/2. Remember, I need common denominators. So the thing about what do I need for a common denominator between 3 and 6? Or 3 and 2, I just told you, I'm gonna need a common denominator of 6. So you gotta figure out what you multiply the top and the bottom by to get a common denominator of 6. Same thing for the next one, okay? 11/12 minus 3/4. I need 12 and 4 to be the same, and I know that 4 can be multiplied into 12. So you got to figure out what do I multiply 4 by to get 12, and then I need to do it on the top as well. So that's going to be your second one. Third problem is multiplication, 2 and 1/5 times 2 and 1/10. So again, if I look, I'm going to say multiply by my denominators, add my numerators. 2 times 5 is 10. 10 plus 1 is 11. So I'm going to say 11/5 times 2 times 10 is 20. 20 plus 1 is 21. And you can absolutely use a calculator to help you with this. Okay, 11 times 21 over 5 times 10 and simplify. And last but not least, we had one of those pesky division problems. So again, I'm going to rewrite a whole number of 5 like this. Okay, keep, change, flip. Keep my numerator or my first number, change this to multiplication and flip this over here. So I just have to do 5 times 5 and 1 times 1. That's all I've got for you today. Thanks for popping in again. Max and Bobby, you guys are new. It's nice to meet you. It's good to see you guys in here. Otherwise, have a great rest of your day. We will not meet next week because there's only school on Monday and Tuesday. So we do not meet next week.